Ernst Rauch, the Chief Climate and Geoscientist at Munich Re, is a world leader in climate and geoscience. As the leader of Munich Re's green efforts, he has a unique insight into how to react to rising climate-related extreme weather events. We are very honored that Ernst accepted our invitation to speak about the impact of climate change on insurance. Please welcome Ernst on our stage.
Good afternoon. My name is Ernst Rauch, as you just have seen. I'm with Munich Re for over 30 years now, 35 years, and I'm Munich Re's Chief Climate Scientist. And I attended this morning a couple of sessions, and I heard, amongst many other excellent presentations, two statements which provide a perfect segue to my intervention this afternoon. The first one was, as an innovator, as a startup builder, think about the problems first before you get to the solutions. The other way around, it's obviously not always very effective. And the second one was, in the future, most likely the demand for new solutions, tech solutions, ventures, will rather be in the space of new risks and emerging risks. And over the next 20 minutes or so, I would like to take you on a journey how Munich Re tackled the challenges from climate change on a digital journey over the last more than 30 years. Munich Re, for those who are not so familiar with our company, we are not just a reinsurance company, we also a primary insurer, own a primary insurer, ergo, and an asset manager. And we use the synergies out of these three elements of our group, reinsurance, primary insurance, and asset management, in order to generate knowledge and to generate solutions for our clients. And throughout my next slides, throughout this brief journey on how Munich Re develops solutions on climate change, which is obviously an emerging risk and a risk of change, we go through this triangle of understanding risk, that's identifying risk, managing risks at the end, and in the middle, you have the measuring of the risks. And the measuring, obviously, is very often, I can say almost always, related to digital solutions. And this triangle also explains at least the first two items, the understand and the manage, sort of the pain point or the access point of ourselves as a risk management company, but of course also of our clients. And more so currently and going into the future and watching what's happening in the markets, it also has become a topic of regulators. And once a topic is on the radar of regulators, for instance, the TCFD-related organizations, Task Force on Climate-Related Regulation, then there is a very concrete need for those who are engaged in climate-related risks to take actions and develop solutions. To highlight the order of magnitude of the challenge, let me start with providing you an insight what's happening around natural disasters over the last 10 years. That's what you see on the left-hand side, and what happened last year alone on the right-hand side. Let me dive you a little bit deeper into what you can see here is. You see on the left-hand side with the green and the blue bars, and on the losses overall, the length of the bar, green plus blue, is economic losses as an aggregate in any given year, years shown here. And blue is the insured losses, and both bars, blue and green, the overall losses. And you see on the left-hand side the scale with in US dollars billion. And if you have a closer look at the data, then you see that there were years in the past where overall economic losses, so for societies, were in excess of 300 billion US dollars. And for the insurance industry, that's the blue bars, we had years, many years in the past, several years in the past, where the overall insured losses exceeded 100 billion US dollars. So that explains why we do have this challenge, this pain point. What you also can see is if you have a sort of a closer look on these bars on the left-hand side, there seems to be a trend, an upward trend towards increasing losses. And that just makes this challenge even more intense. And if you look at time series, which are much longer than shown here on the slide, and that's what we have at Munich Re. We started actually in the 1970s, collecting this data from natural disasters in the past. So we have time series of almost 50 years. They clearly show a trend, and they show a trend much more with weather-related events than with what's called geophysical events, that would be earthquake and volcanic eruption. And that's an indication, not a scientific proof, but an indication that obviously with this trend there are factors driving this trend. And our role is, as a risk management company, to identify these drivers, and for that you need data, you need digital solutions, and yes, you also need experience. You have to be able to put the data into the right context. So that's on the left-hand side, sort of showing you the size, the order of magnitude of the challenge. Now on the right-hand side, that's sort of a glimpse just into the events, the main events of the last years. And you see on the very top, and I'm not going then further down or so, in the US and then in the Caribbean, Cuba alone, there was a hurricane named Ian with overall economic losses from one single event of $100 billion, out of which our industry, the insurance industry, paid 60 billion. So far, historically, this was not the record. The record was Hurricane Katrina in 2005, where our industry paid even way more in today's money. But that gives you the urgency behind the needs of finding more solutions. Now, how did we, as Munich Re, start this, what I called the journey at the very beginning? And it goes back, as you can see here, back to the 1970s. And all started with getting engaged with scientific organization and data provider. Back then, these were almost always weather services, weather organizations, most of them public, some of them private already. And we then put all this information together in the form of this wall map of natural hazards, or world map of natural hazards, in a fully analog form 50 years ago. And over time, and then now fast forwarding here to the far right-hand side of this slide, more and more this information has been digitized, and it's now fully offered as a SaaS solution, software as a service for our clients. So what we did was we started collecting our data. We used it for our internal underwriting processes, for our clients, client-related services, and now we have commercialized the data and the software around this data. Why is it so important to have a good technical understanding of this emerging risk, of this challenge? What you see on the left-hand side, I think many of you are aware of this. That's just showing you the temperature trend as the global average temperature over the last 100 plus years, 140 years actually or so. And you see the world has warmed up by something in the order of 1.2 degrees centigrade. Now, what does it mean for a risk management company and for a company or organization and right down to individuals who are having either a business in the space of weather sensitivity, or us who have to tackle the challenges of hot days, dry spells, and others? And here you see the curve in the middle. The curve in the middle is coming from the IPCC, that's the Intergovernmental Panel on Climate Change, so that's science. And what it should indicate and tell you is what it actually means when we talk about climate change is not necessarily that the world has warmed up by this 1.2 degrees centigrade. If it would be a little bit warmer today, perhaps a little less comfortable or so, but that's not the risk we're having or so. What you see with the dotted bell-shaped curve is sort of the probability distribution of temperatures in a given year. And you see it's a bell-shaped curve or so, and you see there were probabilities or chances that there was a cold year or cold day or cold spell on the left-hand side, indicated with the blue triangle. And on the right-hand side, that's sort of the hot spells, the hot days. Now, if you change this warming, this global average temperature, by just 1.2 degrees centigrade, or just by an incrementally small amount, that's indicated then with this solid bell-shaped curve, you see that the tail of this distribution is changing very much. The probability indicated by this orange and also by the red triangle is changing not just a little bit, as many might feel that 1 degree centigrade doesn't mean much. The probability of extremes, and that's what we call risk, and that ends up on our balance sheet, changes significantly. Now, and on the right-hand side, that's sort of the result, the extremes, and when it comes to natural catastrophes, weather-related catastrophes, we observe these changes, and we do have strong indications that many of these changes are already driven by climate change, so by this global warming. Why am I telling you this in the context of venture building and technologies? It should give you an insight that it's not just about data and digital solutions to analyze the data. Especially this curve in the middle is an area where in the past we realized that in these venture building processes there were still gaps with respect to being connected enough to science and understanding what this curve actually means than when it comes to solutions going forward. I mentioned at the very beginning of my intervention or so that more and more organizations are affected by climate change, either directly through changing physical risks or by their clients, by regulation, by reporting requirements, and others. And on the left-hand side, you see one group of clients where we engage more and more, not just in dialogues, but in very concrete negotiations when it comes to identifying risks and then finally also managing the risks. And that's the financing sector. If you think about banks and project financiers who have certain risks, for instance, mortgage risks on their balance sheet for 20 or up to 30 years. And if there is a change in the underlying hazard for windstorms, for flooding, so the underlying probability as indicated with these curves in the last slide or so, then obviously that has an impact on the risk these companies, these organizations taking on their own balance sheet, mortgages, investments, long-term investments alike. And on the right-hand side, that's just a glimpse into that more and more also businesses, normal businesses, everyday businesses are getting engaged into the question of, does climate change impact my own business? And or do I have to fulfill certain reporting requirements in the near future? And here they need support, they need services, they need solutions. And these solutions, many of those do already come, and I'm very positive that will even more come in the future from new tech companies. It's very much about tech companies, insurtechs, but with the one big exclamation mark, with the experience and link to the underlying science and understanding of regulation. Now I would like to provide you with an insight into two types of software solutions or models which our industry is already using today. The one which is shown here, the development actually goes back to the 1980s, and it was a spin-off, a startup in the US, Stanford University, who really for the first time, it was in the 1980s, developed a CAT model, a catastrophe model, which should help our industry to have a better understanding of loss probabilities if we underwrite a portfolio with earthquake risk or other risks. They started actually with earthquakes. And what you see here in a very generic way is how these models have been developed, what the components were, and as of today, 40 years later, the models still have more or less the same components. The refinement, the learning was with the individual components and not the overall setting. And what you see here is the risk indicated as the expected loss, or average annual loss, as very often referred to. The dollars, the annual dollars of losses or losses from individual events are comprised of these three elements. Hazard, so that's the probability of events occurring. That takes me back to these two bell-shaped curves, and the underlying change. So what's going to be sort of the probability going forward into the next 5 or 10 years, as we no longer can rely on the data of historical events over the last 50 or 100 years or so. That's the hazard component. Then the knowledge about exposure, so the understanding of what do we actually insure or reinsure. In the past, we didn't have sort of the full information about not just the location of this risk, that has improved significantly, but about the physical parameters or the physics of buildings or infrastructure elements. Now, this information is much better known, and that's all about data, the access to data, and the degree of details. And the last one is the vulnerability, the response of a building or an infrastructure element to a major natural disasters, to flooding, to windstorms or so. And that's sort of the history of these elements, still used today, but a lot of need there to go further and improve the degree of details as shown here. Now, what is relatively new is what is shown here with respect to measuring risks on a location basis, called here location risk intelligence. You have seen this world map of natural hazards with this what's called hazard zones from the 1970s and then onwards or so. And as of today, digital solutions which are used not only internally for underwriting processes, but used by our clients to better understand and have better information, for instance, in the asset management space, when they invest into a new office building anywhere in the world. They digitally look at any location in the world and look at the current hazard situation, like flood zones, windstorm zones, earthquake zones, and these systems today provide as an answer to these clients score values, or even can go much further, financial impact, so that's expected losses. Now, what more and more is requested and where there is a demand, and the pain point obviously as well, is having a look at individual locations or to the question, what's going to be the situation, the location risk from flooding or so in 20, 30 years' time, asset managers, mortgage managing companies or so. And why do they ask these questions? Quite rightly so, is because climate change, depending on the further developments of the warming and the emissions behind the warming, change the underlying hazard situation. And so this is the tools, the software solutions, which are not just work in progress, they're already offered, but we are, quite frankly, with such solutions at the beginning of a development. Understanding the consequences, the physical consequences and impact from climate change is a must going forward, those who are engaged in businesses and have assets in that space. And to give you a very concrete example, and I hope you can see it up on the big screen here, is on the left-hand side, there are the Philippines, so that's the country behind this, and with these blue dots or so, you see an investment portfolio from an artificial client in this country. It could be an insurance portfolio as well, and there are two questions answered on this slide. The first one is looking at the geographical distributions, at the locations of this portfolio. How many of these around about 3,000 locations are at high risk, medium risk, and low risk? And this is what you can see with the circle on the left-hand side. And here with this artificial portfolio, the output or the answer is only 7% of the locations are in a high-risk zone, and the focus here was on tropical cyclones, on typhoons. The same analysis could be done for flooding, for wildfires, and other perils. Now, on the right-hand side, you see the answer to the same portfolio under a certain climate warming scenario. The scenario is from the IPCC, and the scenario is here sort of the warming, which is called RCP 8.5, which I don't want to go too much into detail. And you see here the same portfolio is changing towards a higher risk situation. From 7%, now 28% of the locations are in high-risk zones. And those who use these tools can optimize the portfolio, can take out and identify those locations who are at high risk and take them out and minimize the average risk in the portfolio, or they can start charging higher premium or taking any other informed actions. That's sort of the output and the use case for such a tool. Now, from risk analysis, so the measuring of the risks in this triangle, understand, measure, manage, to my last point, measuring and managing the risks. Now, here also more digital solutions and more innovations and perhaps startups are needed to improve what we already have today in still a very sort of coarse way. Parametric solutions where the payout of the insurance company, primary or reinsurance company, is not based on the actual loss, which especially in emerging and developing countries is very challenging because the entire process of defining the loss depends on many factors, including sort of the legal environment, which can be challenging. Now, parametric solutions have sort of the big positive side that you just base on meteorological data or seismological data, independent data and independent sources like a weather agency. And here this cut in a box or cut in a circle is an example here for tropical cyclones or hurricanes here in Canada. And for us as a risk management company, and when it comes to managing the risk and developing solutions, that's one way of providing new risk transfer solutions to our clients and customers who in the past either were not able to get this insurance for many, many reasons, but especially when we think about emerging and developing countries where there is a strong need there and there's a huge lack of data, a lack of information to do sophisticated underwriting analysis, and such solutions help out a lot. Let me wrap this up. What I wanted to tell you in the course of the last 20 minutes or so is when it comes to new and emerging risks, changing risks, and my example was climate change. First of all, we do see a strong demand for new solutions, digital solutions to understand and manage these risks, and ultimately also to manage risk in a way that they can be put on the balance sheet of an insurance or reinsurance company. The, data and experience, and here I would underline experience, are sort of the main ingredients for such solutions. Collaborations with scientific organizations are very helpful to better understand what's happening with these new risks. And last but not least, Munich Re is not only continuing and committing to investments into these solutions, we are working with on the development of refining our CAT models. We're also working in the venture space, working on these models. So for us as a reinsurance company, these developments, including new digital solutions, are the core of further business development. We won't grow in that space without having these tools available. I would like to thank you so much and wish you great discussions later today. Thank you.